In this lesson, we'll learn about the sheen component of the standard surface shader and how to create realistic fabric shaders in Arnold for Cinema 4D using the sheen component. If you take a look at this reference photo, you can start to see what makes fabrics look like fabrics. Look how the faces or polygons that are parallel to our viewing direction are darker, and the perpendicular faces to our viewing direction become fuzzier and brighter. If you can simulate this, you can get realistic fabric shaders, and this is what sheen component is supposed to do. Sheen basically simulating microfibers and cloth-like surfaces or any sort of fuzziness on a face, on fruits, and so on. Before creating any actual fabric shaders, let's take a look at the few parameters in the sheen section. For a realistic fabric shader, you only need the base and the sheen component plus any bump, normal, or displacement mapping. So for now, we can zero out the specular weight, set the base weight to 1, and use a dark gray with the RGB values of around 50. In the sheen component, let's set the sheen amount to something like 0.5, and the sheen color is set to white. We immediately get that fuzziness at glancing angles. You notice how the parallel faces to our viewing direction are showing the defined darker base color, and the perpendicular faces are showing the defined white sheen color. In addition to that white color, sheen component also adds that feeling of fuzziness and cloth by simulating microfibers. We have the sheen color that controls the color of the microfibers, and generally this should be a brighter, less saturated version of the defined base color. For now, let's keep it at white. We also have this sheen roughness, which modulates how much the microfibers diverge from the surface normal direction. Basically, using the roughness value, you can control where that fuzziness begins. By increasing it, it begins at lower angles from the parallel faces, and by decreasing it, the fuzziness starts at higher angles from the parallel faces. If I set the roughness to 0.1, you see how the sheen effect is limited to very extreme glancing angles. And if I increase it and set it to something like 0.6, now that sheen effect is more widespread and starts earlier. So that's about the sheen component. Now let's make some realistic fabric shaders. First, we try to create a purple velvet shader. So create a new standard surface shader and assign it to the geometry, and open up its network. As always, zero out the specular weight. Set the base weight to 1. For the base color, use this dark purple. So basically, the base color is going to be a dark version of the color that you have chosen, and the sheen color would be a brighter, less saturated version of that color. You notice it doesn't look like fabric at all because we still don't have that previously described attributes of fabrics. For something like velvet, set the sheen weight to 1 and sheen roughness to 0.1, 0.2. You can experiment with these parameters. And for the sheen color, let's use a brighter, less saturated color compared to our base color. And now, as you can see, we get this nice velvet shader. Let's go for a blue velvet. I'm gonna just copy the purple velvet shader and assign it to the geometry and open it up. To create a blue velvet, you just need to obviously adjust the base color and the sheen color to a dark blue and a less saturated, brighter color like a pale blue. And now you would have a nice blue velvet shader. If we bring up the reference picture again and zoom in a tad, you notice we have this kind of fabric pattern throughout. So let's add this pattern as well. I'm going to duplicate the purple velvet shader and assign the new shader to geometry. Now open it up and load this fabric pattern image. And we want to use this as the bump map. So connect it to the bump map input of a bump 2D node. And connect the bump 2D node to the normal input. And as it is velvet and that pattern is not that visible, set the bump height to something low like 0.2 centimeters. If we connect the fabric pattern image to the beauty port, you notice it doesn't sit quite well on the geometry. So let's set the tiling of the fabric pattern image to 0.2 and 0.2. Now it looks better. Now connect the standard surface to the beauty port again and let's see what we get. And now we have this beautiful fabric pattern as well. Now let's create a crushed velvet, something like this photo right here. For this, let's duplicate the original velvet shader and open up its network editor. We need to have two base velvet shaders. One should be fairly brighter than the other one. Then we mix the two to get the final crushed velvet look. Let's duplicate the standard surface shader again. Now let's use a brighter base and sheen colors compared to our base shader. Now add an Arnold layer shader and connect it to the beauty port. Layer shader basically allows you to stack up and mix shaders. Connect the darker velvet shader to input 1 and connect the second velvet shader, the brighter one, to input 2. Now to mix the two, load this map called BW8, this black and white map. And use it as the layer 2 mix input. If we set the BW8 as the beauty shader, we can set its styling to something like 0.2 just to get a better result. Now connect back the standard shader and let's see what we get. And now we are getting this nice and realistic crushed velvet shader. Next, let's create a simple upholstery cotton fabric shader. So let's create a new Arnold standard surface shader and assign it. And zero out the specular weight. Load this fabric pattern image again, and obviously you can find your own fabric pattern images online. There are tons of them, and use them instead to get different patterns and different looks. I'm going to set its styling to 0.2. As this is going